Hi, today we're going to learn about negative indices. We are asked to simplify and express the following in terms of positive indices. Do you remember how to simplify this? Yes, given the same base, we can subtract the power, and hence we have 5 to the power of negative 2. Now if we do a direct calculation, it will look like this. If we cancel out the common terms, we will get 1 over 5 to the power of 2. Hence, 5 to the power of negative 2 is the same as writing as 1 over 5 to the power of 2. Next, we'll see 2 more examples. How do you simplify this? Similarly, we will subtract the power, and hence we have 4 to the power of negative 3. Now, if we do a direct calculation, it will look like this. And cancelling out the common terms again, and what do we get? Yes, we have 1 over 4 to the power of 3, or 1 over 4 cubed. Since we started out with the same expression, therefore 4 to the power of negative 3 is equals to 1 over 4 cubed. Now simplify 7 to the power of 2 divided by 7 to the power of 3. We will once again use the law of indices, and hence we have 7 to the power of negative 1. Finally, we will solve the same expression using direct calculation, and this is what we will get. Cancelling out the common terms, and we will have 1 over 7 to the power of 1. Now the 1 is invisible here. And in conclusion, we have 7 to the power of negative 1 is the same as writing as 1 over 7. Now what happens if our base is a letter of the alphabet? Let's say A. Okay, no problem, we can still use the law of indices, and we'll get A to the power of negative 3. Similarly, we will now use direct calculation, and cancelling out the common terms, we will have, yes, 1 over A to the power of 3. Likewise, we will get A to the power of negative 3 equals to 1 over A to the power of 3. Take a moment to look at these examples. Do you see any pattern? 1 over 7 here can be written as 1 over 7 to the power of 1. Have you gotten it? Given the base A and the index negative n, the negative here actually represents a reciprocal or an inverse. In simple word, it means it is 1 over, and we can rewrite it as Now, I'll show you the animation once again. We will bring down the base and the index without the negative sign. And the negative sign will actually change into 1 over. Now, this 1 over is called the inverse or reciprocal. Hence, A to the power of negative n can be written as 1 over A to the power of n. And this will be our 7th law of indices. You also have to take note that 1 over A to the power of n can also be written as A to the power of negative n. You do not need to worry about which law of indices this is. However, you do need to memorize all the law of indices that have been or will be mentioned in this chapter. Well, just something to take notes here. 1 over A is actually 1 over A to the power of 1. The power 1 is actually invisible here, and hence we can write it as A to the power of negative 1. Now, to check whether you have truly remembered or understood what you have learned just now, we will try to answer some of these true or false questions. Is this true or false? it is false. Because this term here is positive, whereas this term here is negative. Is this true or false? You're right, it is false again. This term is positive, and again this term is negative. Is this true or false? Well, it's false because we have converted the negative power to an inverse. However, the negative sign is still here. Is this true or false? Finally, this is true using our law of indices. Do you get all of them correct? It is easy to make mistakes, therefore memorize the law of indices well. So what have we learned so far? We have learned the first 3 laws of indices with the same base, the next 2 laws of indices with the same powers, the 0 law of indices, and for this lesson, we have learned about the negative law of indices, where a to the power of negative n is equals to 1 over a to the power of n. That's the end for this video. In the next video, we will learn more about fractional indices.